Okay, I hope we have sound. I just one of your classmates, Nicole, sent me an email saying, "Hey, I don't have enough information to be able to solve this problem." Well, actually, you do. It's in your textbook. But did we go over it in class? No. Did I ask you, have we done a solenoid yet? And everyone went, Of course, you wouldn't have any idea what a solenoid is. So basically, a solenoid is a curlicue thing, all right? And I'm going to call up my ladybug here. It's a curlicue thing. It looks like this. It's just a long coil of wire. And remember, we were talking about that's wrapped a bunch of times, okay? And the magnetic field that it produces for a solenoid, the magnetic field for a solenoid is equal to mu naught I. Yes, that mu naught, which is the permeability of free space, times I, times N. So it equals mu naught N times I. And what is N? N is equal to turns per meter. So if you have something that says, hey, I have a solenoid. Here's a typical example. Solenoid that's 20 centimeters long with 20,000 turns, which with certain machines you can do that. Then N would equal 20,000 divided by 0.20. Okay. All right. So in this problem, and real quick, I'm kind of like going, well, are you sure about that? Let me double check the formula for solenoid here with you. I'm going to make you suffer through this. Where the hell is sorry. Boy, here we go. Magnetism, electromagnetic. Two parallel conductors, Ampere's law. Loop, magnetic force, torque, currents. I think it's more applications of magnetism. Yeah, where we get into solenoids and stuff, magnetic resonating things. Okay, those are just kind of fun stuff to know. Yeah, I'm right. Here it is. Right, we go, what the heck is all this? Yeah, that's all that. But then where is our definition of a solenoid? Here it is. The field strength of a solenoid. So here it is. Yeah, I was right. Mu naught times Ni. Yep. Mu naught times Ni. That's inside a solenoid. So here's one. But that's 2 meters long, has 2,000 loops, and carries 1,600 amp current. What's the magnetic field? All right. In this problem, we are given. So let's go back to this problem. It says consider a long closely with 10,000 turns. Oh, they gave us N. How hard is that going to be? And then what current is needed in the solenoid to produce a magnetic field inside the solenoid near its center that is 10 to the 4 times the Earth's magnetic field? Well, you just take 5.25. Some of you have 5.16. Some of you have 5.18. You take 5.25 times 10 to the 4th. All right, times 10 to the negative 5th times 10 to the 4th. So what do you get? You get 0.525. Okay, 0.525 would be my I can't talk magnetic field here because I'm looking at the clock. At 2 o'clock, I got to go get in the car to take my wife to the bionic woman there with her new shoulder to take her to physical therapy. But anyway, she's been great. I mean, she got a whole new shoulder, and she's taking nothing but Tylenol. She's a beast. I'm sure she loves that I just told 100 physics 220 students, yeah, you're a beast. Anyway, so B. So let's go back to the ladybug. let's go back to our problem. Oh yeah, so mine was the Earth's magnetic field, B of the Earth, is equal to 5.25, and it varies, times 10 to the negative 5 Teslas. Okay, and in fact, they'd call that 0.5 Gauss or something, because a Gauss is 10 to the negative, or 5.25 Gausses, because Gauss is the one who kind of measured the magnetic field, and it came out, this is a Gauss, right? And he gave us all this electricity stuff. So, but we want B to be is equal to BE times 10 to the 4th. So this would come out to be 0.525 Teslas. And so what we're after here, and it had, how many turns did this one have? 10,000. Oh, N is equal to 10,000. Well, this is really easy then. And we've got to find I. I know it was an easy one because I just wanted you to see solenoids real quick. So we've got 0.525 is equal to mu naught times 10,000 times I. Okay, mu naught times 10,000 times I, which is kind of a screwy number. So so if I take mu naught, I'm sorry to do this, make it so small. Well, I'll put it on 2 sheets. So I've got 0.525 is equal to mu naught times 1 times 10 to the 4th times I. So if I've got 4 pi times 10 to the negative 7, yada, 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 times 1 times 10 to the 4th, that's E times I get 4 pi times 10 to the negative 3 times I. And 4 pi times 10 to the negative 3, we can do pretty quick on the old calculator here. Turn that puppy on, and we get parentheses 4 second pi second e to the negative 3, not 7 this time, is equal to 1.25 times 10 to the negative 2, 1.257. So 1.257 times 10 to the negative 2. So 1.257 times 10 to the negative 7 is a good approximation for this if you want to just kind of put that in your calculator instead of having to do the 4 pi every time. Okay? So if I take 0.525 divided by that, so I'll take 0.525 divided by second answer, boom, and I get 41.7. Let's go with 41.8 amps. Yes, you need a lot of amps to go through solenoids to create huge magnetic fields. So the amount of amperage that goes through a thing. So let's see if this is right. If it's not right, I'm gonna maybe I should make that 41.8. Yeah. Submit to me, you dog. Yes, we are. Spot on. What? Oh, they went 4 sig figs. Why would they go 4 sig figs when nothing in here is 4 sig figs? Nothing. This is 1 sig fig. This is 3. But they give me the answer in 4. Yeah. All right, so you got it? Out of here.